Okay. Okay. So hopefully you're better at this. You're getting, when I wrote these worksheets, I was thinking, okay, what can we do to kind of jazz up some of the problems that we have the kids do? And, I put the graphs right here, and my wife drew these. She's really a pretty good artist. She likes to do little caricatures and stuff. And so anyway, how'd this go? Was there any of these that well, first of all, did we need a little review of graphing lines? I think probably so, because it's been a week or two since we did one, and so I think that's good. Everything we do kind of has a purpose. It's just not just to try and keep you busy. Were there any of these you want to take a quick look at? 8. Number 8. Okay. Let's smoke through this like a teenage delinquent through a pack of unfiltered Camels. Okay. Yeah, exactly. Don't smoke, kids. Okay. So here we go. On this one, first thing I'm going to do to make my life a little bit easier with this, can we divide by 10? I think it might make our life easier. So what the heck, let's do it. 3x plus 5y. I'm going to move this over also equals 10. Okay. So if we want to, we could do this one a couple different ways. We could say, let's find my x and y intercept. First of all, I'm going to make sure I didn't make a mistake. Good. My y-intercept is 2. My x-intercept is 3 1/3. Okay. And then I'm going to take my ruler that I bought this weekend at Dollar Tree. Made a big investment in rulers this weekend, I did. And the other one, do you see anything we can divide this one by? 3. Let's divide this one by 3. Let's make our life easier. And let's go ahead and move that over 10. My x-intercept is 10. Ah, crud. This thing isn't that big. I can do my y-intercept though. So if my x-intercept or my y-intercept won't fit on this, how else could I graph this? What else could I do? Find my slope? How? Yeah. So we're going to go ahead and get y by itself. No, negative 5. I'm trying to do 2 steps at once here in my brain. That was really ugly. Come on, Rex Road. Okay. So this one, negative 2. So I'm going to go up 1 over 5, up 1 over 5. And we're going to get that point right there. It looks like they come together right there. If you're graphing, how accurate would you say solving by graphing is? Is accuracy its strong point? Let's put it that way. Probably not. Okay? But I'm thinking, let's see if we go 5, negative 1, is that here somewhere? Yes. Okay? It was 5, negative 1, right, for this one? Okay, good. So yeah, but if you want to get y by itself without dividing by 10, dividing by 3, you definitely can. But that was a good review of doing it both ways, finding your x-intercept, y-intercept, and getting y by itself. Okay? On number 36 from the book, you were supposed to do that as well. So this is Alicia. Alicia, after 0 days, had 450 pages left to read. After 5 days, had 100 pages left to read. So hence her slope was negative 70. And so then here's my equation. Why can I just write it like this? I don't need point slope because that's my y-intercept. Negative 70 pages per day plus 450, and that's the pages in the book itself. 6.4 days if you do the algebra. So how would you answer this? 6 days or 7 days? 7. Yeah, because 6 days they're going to have 30 pages left, and then 7, and then they're going to have it finally whipped. Question. When you guys have a book... Exactly. Let me finish. How many pages would you guys read a day? 0? Or let me phrase it this way. How long would it take you to read 70 pages? Could you do it in an hour?
Maybe like 2.
2? Okay. Because I'm a slow reader myself. You know, I've got to sound out all the words and look half of them up in the dictionary, stuff like that. But I don't know. They say that actually reading is one of the great avenues to just a higher level of intelligence. They say that people who read more are usually pretty darn smart. Okay, so let's move on. Move on to kind of new stuff, but not new stuff. So tuck this away. Don't lose it because I'm going to assign something else on that later. Here we go. Where's my notes? Here it is. Okay. So we're talking about solutions of systems. We're in section 2.4. Okay. God dang. I forgot to shave. It gets itchy. Anyway, I feel like a Santa Claus homeless man or something. I don't know. Let's solve this one. So if I got y equals negative 1/2 x plus 3, and I go 2x plus 4y equals 12, okay? We are going to have our first visit from a character that I like to use in math class every once in a while, called the dumb math teacher. And no, I don't need your smart comments like, oh, I think he's here every day. That's very hateful. Okay, so what we have to do here to solve the system by graphing is to graph the first one and then graph the second one and then see where they intersect. But I forget how to graph these. How should I graph this top one? What do I do?
Y-axis is 33. So go plot it on your y-axis for 3.
Which one's my y-axis?
3.
Up 3. So, okay, hold on. 1,
No.
2.
Starting at the 0 axis, go up 3. 1.
Go up 3?
Yep. 1. No. 2. Yep. 3.
3. Okay.
Put a dot.
Put a dot. Okay.
That's enough.
Okay. Sorry. Okay.
Okay. Now you're going to go
From that
down
point.
1.
From that point.
From the point.
That's where, oh.
No, the dot.
Oh.
Go down 1. Right. 2. Oh. Okay.
Put a dot.
Put a dot. Negative. Okay. You can just draw a line. Yeah, you connect. No, connect them. Okay. You see where the big dot and the little dot is? You make a line between it.
Okay. Now, out of all seriousness, when I do this, if I know my slope is negative 1/2, I'm going to try and go through another point over here that shows the same slope. I'm not just going to kind of hit those 2 points. I'm going to try and hit more. So anyway, okay, that one. Okay, now, okay.
Okay, next one.
Yeah, next one. Okay, what?
Minus 2x.
You only get to one side.
Okay.
that's from the 2x to the left and the 2 left and 12.
Can I just
You can just find the
what's what?
X, a dot on the horizontal line at 6. So go over 6.
from the
2, 3, 4, 5, 6. Now put a dot. Okay. Okay, now on the vertical line, you're going to go up 3.
Oh, I should have used a different color. I'm going to get confused.
Okay. Up. Wait, it's the same thing. Yeah.
It's the same thing.
Good job, you figured that out.
So what does that tell me about my solution set? There's no solution? Oh, so this is a different scenario than we've seen. I didn't put it on the worksheet when I was writing that worksheet. So this is a situation where, even though it's not obvious, these two lines are the same exact set of points. They're written in different forms. Okay? So how would we say what our solution set is? Well, how many points do these lines have in common?
all of them.
All of them. So it's all points. So like, does this point work?
No.
Does this point work? So all points where?
Online.
On y equals negative 1/2 x plus 3. So how many points are there? There's infinitely many points. This is what's called a lemniscate. It's a shape that shows up lots of times in mathematics. It's kind of cool. I even have a shirt with a lemniscate on it. It's kind of neat. From one of my favorite bands, Hoobastank. But anyway, yes, that's a band. So anyway, they're both. The book's going to talk about consistent, inconsistent, stuff like that. I'm not going to worry about that today, okay, because we were kind of short on time in the other class, so I want to make sure we had enough time to do homework, okay? So this one, I just want you to know that they are the same line. Why are they the same line? Because they have the same y-intercept. They have the same slope. So if I would have taken Ethan's advice, which was a brilliant way to do it, I would have came up with the idea that for y equals negative 2x plus 12, I would have got y equals negative 1/2 x plus 3. Okay, dumb math teacher showed back up again. And notice it's the same exact one. So a good way to see how many solutions there are is to get them in y equals form. If they're exactly the same, there's infinitely many points they have in common. Okay? Okay. Let's do another one. I really am impressed by your hallways, to tell you the truth. I'm kind of floored. Wow. The effort and the creativity that I saw. It's impressive. It's impressive. You guys have some things going on here at West Point that you need to be very proud of, and not all schools have that. So you guys should be proud of what you guys got going on. Okay. And I am taking. I haven't voted yet for the hallways, so I am taking bribes for which hallway gets first, second, third, and fourth. Okay. So just
No popcorn?
what?
No popcorn?
Popcorn? Ooh, that might help.
Tickets to 9/11.
Tickets to 9/11?
9/11. I meant 11. No,
Tickets to 9/11. Okay. So one of my students, I'm not going to name who they are, wants me to go back in time and attend 9/11. Oh my. It's nice to be loved by my students. Okay, here we go. So if we have this scenario, one thing I want you to notice is there's kind of a pattern here. Are these equations the same? Are they kind of different forms of one another? Well, we can take a look. This one's times negative 2. This one is times negative 2. But this one is not times negative 2. So are they the same equation? No. They're not. So if I get y by itself, they're not going to be the same. So if I would graph this real super quick, I'm going to try and save you time. My y-intercept here is 1. My x-intercept is 3. And then I'm going to get this line right here. Okay, I probably should have drawn that with a ruler, but I know what's coming. My y-intercept here is -2. My x-intercept is -6. Oh, whoa. No, I went down 1 instead. I'm sorry. Okay. So those two lines, what's my solution set? No solution. No solution. They do not have any points in common. Why don't they have any points in common? Because they have the same but different y-intercepts. Okay, so here's what we're going to do. We're going to make a little summary of what's going on. So we've got, you all right?
Yeah.
We have 3 different scenarios. Okay, so let's take a look at this. So how many solutions? How many solutions to this system? 1. That's where they intersect. How many solutions to this system? Infinitely many. How many solutions to this system? None. So now let's take a look at this, the slopes. The slopes here of this line, of these two lines, they are different. Anytime your slopes are different, they're going to intersect. Because they have different angles. They're going to intersect at some point in time. Okay? Yeah. So slopes, what about this one? What can you say about the slopes? Same slopes, but also the same what? The same y-intercepts. Okay? This system right here, what's true about this one? Same slopes. And my y-intercepts are different. Kim, you need to go to the main office. Okay? So these have the same slopes and the different y-intercepts. Okay? So I'm going to save you guys some time here. And I'm just going to show you what we've already done. If you get y by itself, and they have the same slopes, same y-intercept, they're the same line. And you have infinitely many solutions. On this one here, if I would have gone back, I would have got y equals -1/3 x plus 1. This one would have been -1/3 x minus 2. Same slope, different y-intercepts. They have no points in common. Okay? So those things are good indicators of when you're going to have solutions and when you're not. Look at the slopes. Look at the y-intercepts. Okay. So by skipping through that, we kind of have a little bit more time for this last one. Cars. I'm a huge car fan. I love cars. I was reading last night about the new Corvette that they just released the info for. It's insane. 250 horsepower to the front wheels with electric motor, 1,064 horse to the rear wheels via a internal combustion engine, and goes 0 to 60 in under 2 seconds. And it's crazy fast.
I'm going to pretend like I know it's
Crazy fast.
That's crazy.
It is nuts. And it's going to be an expensive car. It'll be over $200,000.
You should get one. Would you get it?
No.
If you had the money?
If I had the money, I would have to have a ton
How much
of
would it cost?
money. $200,000. But the insurance would be crazy expensive. The taxes on it would be expensive. And right now, I don't ever foresee myself being in a situation where I'm going to buy another Corvette, probably.
Another four?
I've got two right now. Yep. So, when we paid off our house early, my wife and I sacrificed a lot to pay off our house early. So when we did, we're like, you know what? We just saved $50,000 in interest. Let's treat ourselves to something. And we found a Corvette in New York that we liked really well, and it had exactly all the equipment that we wanted, and we had it shipped out. So,
You start to school one day.
I should, but that one, that Corvette, I don't have insurance coverage on it that lets me drive it to work. The other one, I do have insurance coverage on it that lets me drive it to work. Because if you get insurance coverage that says you can only do this, that, and the other with it, the insurance gets a lot cheaper. So that's why we did that. We can only drive it like 3,000 miles per year, and I can't drive it to work. The other one, I can drive it to 5,000 miles per year, and I can drive it to work. So maybe we'll do that. Okay. But anyway, so we got two different types of cars. We got electric and gas. And this is just data pulled from the textbook. I don't know how incredibly accurate it is, but we're just going to work with it. So initial cost is $29,000 for electric. Okay? I'm kind of trusting the book here that their data might be somewhat accurate. Gas, $19,000. But one thing with an electric, you do get a tax credit. The tax credit, they are getting rid of that tax credit. That's actually one of the reasons why Elon Musk and Trump kind of parted ways, because he's like, please keep this tax credit. Trump was like, no, I don't want. I want to get rid of that. And he's like, it's going to mean less car sales for me. But anyway, that's one of the ways, one of the reasons. But electric, why would anybody buy an electric car then, since they're so much more expensive? Better for the environment. Okay, that jury's still out.
You don't have to pay for gas.
Yeah, you don't have to pay for gas. What do you have to pay for? Electricity. And they're estimating that it is about 0.036 cents per mile to run an electric car, and about 8 cents per mile to do a gas car. So then your equation comes pretty nicely. The cost is 0.036 M plus 29,000. Here your cost is 0.08 M plus 19,000. So we could go ahead, if we solve this by graphing, this is going to cause us troubles. Why? Because it's really, really, really hard, if not impossible, to say, okay, I'm going to start up here. Don't write this down. If I start at 19,000 and then I'm going to go up 8 cents per mile, that's just not going to work well at all. So what we're going to do is we're going to experiment. We're going to find a couple points. So let's go like this. We're going to pick a certain number of miles. We're going to do electric, and we're going to do gas. Let's do 100,000 miles. Who's more gassy, girls or guys? Who's more gassy, girls or guys?
I think girls use more gas.
Okay. Okay, guys are more. Let's have guys do gas. Okay, ladies do electric. So I want you to plug in 100,000 miles to your prospective equation, and then I want you to compare it to your neighbor. And if they agree the same as you, tell me the answer. Okay, here's one. Okay. So guys, gas. I don't know. I think guys are gassier, but ladies, electric. Compare your answer with the neighbor, and if you agree, please tell me what the solution is. This is nuts. Come on, compare. Somebody give you some answers. If you agree with somebody else, tell me. If you agree with somebody else, tell me. Come on. I'm trying to save class time. 32,600 for electric? Okay. Gas, what? 27,000. Okay. Keep it. I got another one we're going to do here, Jason. Okay? Okay? In the last class, we couldn't agree on an answer at all. And you're just typing it into a calculator, 0.036 times 100,000 plus 29,000. And then make sure you have 5 zeros on your 100,000. Maybe that's where the issue is. Let's try 200,000. Same thing. Guys, gas. Ladies, electric. Let me know when you compare with somebody else so you're confident enough about your answer. 35,000 for gas. Ladies.
36,200.
Okay. So here's what I would do. If I was going to graph this one by solving, I've drawn this graph before, so I'm just going to kind of tell you what I did. We're not going to go through the whole thing step by step. But now that I've got points, look what I can do. I can just go ahead and plot this out. I think the hardest thing on this problem is picking your scale. That's why I did all these points first, to find out what my scale needs to be. My miles down here, 100,000, 200,000, 300,000, I went by 20s. 20, 40, 60, 80, 100, 20, 40, 60, 80, 200, 20, da-da-da-da. And then by cost, I knew I'd need something up to 40,000. So I just went 5, 10, 15, 20, 25, 30, 35, 40, stuff like that. So then I plotted my points. This one started at 19, and then after 100,000, it was 27. This one started at 29, and then after a while, it was at 32.6. And I got something like that, about 240,000. Do you think this is going to be exactly accurate? No. Because, there's a lot of estimation going on here. Like, where's 19,000? Where's 29,000? Where's 32.6? So this is just an example of solving and graphing a situation. You will need regular graph paper today, and you might want one of these sheets today as well. But the first problems, you just have to tell me how many solutions there are. The rest of them, I think, graph and solve. Thank you. There's a lot of Smurfs running around today. You run the school. Okay. Okay.
Actually, Gargamel does. Now don't lie to yourself. Gargamel does. He does not run. He hunts. Gargamel does not run.
Okay, on the first three, you don't have to graph them. 2, 4, 6, you don't have to graph them. Just use your algebra and tell me how many solutions there are.
Is that even? Does that say even?
Yes, evens. You can do them all if you want.